Good morning, my dear students of first secondary. I am Mr. George Milad. Today we are going to talk about a new lesson. This lesson is called Types of Roots of the Quadratic Equation. Okay, let's go. First secondary algebra, unit 1, lesson 3, types of roots of quadratic equation, prepared by Mr. George Milad. Okay, let's go. Today we are going to talk about determining the types of roots of the quadratic equation. What are the types of roots of a quadratic equation? We determine the types of roots of the quadratic equation by using the discriminant. Okay? So today our lesson depends on finding the discriminant. What is the discriminant? Discriminant is b power 2 minus 4ac. This is what we call the discriminant. Okay? Again, our lesson today, he will ask you to find the types of the roots, the type of roots of the quadratic equation. How can we find the types of roots of the quadratic equation? By using the discriminant. By using what? By using the discriminant. What is the discriminant? Discriminant is d equals b power 2 minus 4ac. If you can remind the quadratic equation, the general formula, x equals negative b, positive or negative, square root of b power 2 minus 4ac over 2a. This part, the square root of b power 2 minus 4ac, you can see that b power 2 minus 4ac will be denoted by the symbol d, which is called the discriminant of the quadratic equation. Okay? Okay. Now we have three cases. If you calculate the discriminant b power 2 minus 4ac, and the result will be equals positive number. The result is a positive number. Then the equation has two real and different roots. The equation has two real and different roots. Okay? What we mean by that? We mean that the curve of the quadratic equation intersects x-axis at 2 points. The curve of the quadratic equation intersects x-axis at 2 points. This is the first point and this is the second point. Okay? So the solution set here we have two solutions. The first solution will be x1 and the second solution will be x2. Okay? Here also the quadratic equation intersects x-axis at 2 points, which are the solution set of the quadratic equation. So if you calculate the discriminant and you find that the discriminant is a positive number, so the equation has two real and different roots. This is your answer. Since the discriminant is a positive number, so the types of roots are two real and different roots. So the quadratic equation has two real and different roots. Okay. If you calculate the discriminant and the result is 0, okay, and the result is 0. So what happened? Solution set here A and B. Here, if the discriminant equals 0, the equation has two real and equal roots. Your answer will be the equation has two real and equal roots. Okay? here you can see that the discriminant intersect x-axis at only one point. The curve of the quadratic equation intersect x-axis at only one point. Okay, which is A. Here we can write A. Here the discriminant is the curve of the quadratic equation intersect x-axis at the point A. So the solution set will be A. Okay, why here the curve of the quadratic equation intersect the x-axis at one point? Because the discriminant equal 0. Okay, if you calculate the discriminant and the result is negative, the result is negative number. Okay, the result is negative number. The equation has no real roots. The equation has no real roots, but it has two complex roots. Okay, so here the curve of the quadratic equation doesn't intersect x-axis at any point. So in R the solution set will be equal phi. Here we say that the equation has no real roots, but it has two complex roots. Okay, and you can say two complex imaginary roots. Two complex imaginary roots, and the two roots will be conjugate to each other. If one of the root is 2 plus 3i, the other root will be 2 minus 3i. Okay, here the solution set will be equals to phi. Okay, solution set equal phi, but you have to find these two roots by using the general formula, and the two roots will be in the set of complex numbers. Okay, let's start our first part of this lesson. Example 1. Determine the types of the two roots for each of the following. Okay, this is a very easy lesson. This is a very simple lesson. Okay, all that you want to know that to find the type of roots of the quadratic equation, use the formula discriminant d equals b power 2 minus 4ac. Okay, but as we said, as always before, here you have to put the equation in the standard form of the quadratic equation. Okay, so here we are going to distribute negative x. Here we are going to distribute negative x multiplied by x and negative x multiplied by negative 6. Okay, x minus 11, it will be left over, so we will write x minus 11 as it is. Here we are going to distribute negative x. We are going to distribute negative x. Okay, here we are going to distribute negative x. I will change the color for you. Okay, here x minus 11 were left over, minus x power of 2, minus x power of 2. Okay, x minus 11, negative x times x, it will be negative x power of 2. Negative x times negative 6, negative times negative equals positive. X times 6 equals 6x. Here we are going to collect like terms together, and it will be arranged. We are going to arrange the equation in the standard form of the quadratic equation. We all know that the standard form of the quadratic equation is excellent, ax power of 2 plus bx plus c equals 0. But here we have negative x power 2. We don't want the coefficient of x power 2 to be negative. So negative x squared will go to the other side, and we are going to collect x and positive 6x. It will be 7x. 7x will go to the other side. It will be negative 7x. Okay, here negative x squared will go to the other side, and 7x will go to the other side. Let's write it together. Here, x plus 6x, it will be 7x minus 11 minus x squared equals 0. Here you have two solutions. The first one is all the terms of the quadratic equation go to the other side by changing its sign. Or you can multiply the equation by -1 to make the coefficient of x squared is positive. Okay? It's preferable to make the coefficient of x squared is to be positive. Okay? Okay, let's go to the steps of solution again. Here you can see that, wait a minute, just a minute please. Here you can see that now x power of 2 minus 7x minus 11 equals 0. Now we put it in the form of the quadratic equation. Okay, let's calculate the discriminant. Here a equals 1, a equals 1, which is the coefficient of x power of 2. b equals, very good, b equals -7, the coefficient of x, and the free term is -11. So c, it will be -11. Let's calculate the discriminant together. Here, the discriminant equals b power 2 minus 4ac. The discriminant equals b power 2 minus 4ac. b power 2, -7 for all power of 2, minus 4 multiplied by a, which is equals to 1, multiplied by c, which is equals to -11. Okay? Here, -7 power of 2 minus 4 multiplied by a1 multiplied by -11. The result will be, the answer is 93. So you will ask yourself, 93 is a positive number or a negative number? Very good, 93 is a positive number. So the discriminant is positive. So you will write the quadratic equation has two real and different roots. This is your answer. It has two real and different roots. Okay? Don't find the roots. Here we don't want to find the solution set. We want to find the roots only, the type of roots. So the answer of this problem will be, it has two real and different roots. Okay? Let's go to another example. Here, 2 plus 9 over x, 2x plus 9 over x equals 6. Okay? Here, again, x plus 9 over x equals 6, where x not equal to 0. Here you can see that this is not the standard form of the quadratic equation. So first we need to put it in the standard form of the quadratic equation. How we are going to do that? By multiplying all the terms of the equation by x. Here we need to get rid of x in the denominator. As I told you before, here in this equation you have to get rid of x in the denominator. How can we do so? By multiplying all the terms of the equation by x. So here x will be multiplied by x, it will be x power of 2. 9 over x. 9 over x. Okay, here we are going to multiply 9. I don't know, today the color is not working. Here we are going to multiply 9 over x multiplied by x. Here the x cancel x. X will cancel x and the remainder will be 9. Okay, so multiply the both sides by x. X multiplied by x will be x power of 2. 9 over x multiplied by x, it will be 9. Equal 6 multiplied by x equals 6x. Okay, then 6x will go to the other side by a negative number. Here x power of 2 plus 9 equals 6x. 6x will go to the other side. So the equation would be x power of 2 minus 6x plus 9 equal 0. Okay? X power of 2 plus 6x minus 6x plus 9 equal 0. Now we want to determine the types of roots. How can we find the types of roots? By using the discriminant. What is the discriminant? D equals b power 2 minus 4ac. Okay? So here a equals 1, b equals negative 6, and c will be equals, excellent, c will be 9. By using the discriminant, b power 2 minus 4ac. Okay? b power 2, negative 6 power of 2, minus 4 times a equals 1 times c equals 9. The result will be 0. So the discriminant equals 0. Let's revise together. If the discriminant is a positive number, so the quadratic equation intersects the x-axis at 2 points. So it has 2 real and different roots. Here the discriminant equals 0. This is the second case. When the discriminant equals 0, the quadratic equation has 2 real and equal roots. So we will write that the discriminant equals 0. So the quadratic equation, it here refers to the quadratic equation, has 2 real and equal roots. Okay? It has 2 real and equal roots. Example, x minus 2 over x minus 1 equals 4. Okay, where x is not equals to 1. Here we want to get rid of x minus 1 in the denominator. Here we want to get rid of x minus 1 in the denominator. How can we are going to get rid of it? By multiplying all the terms of the equation by x minus 1. Okay, we are going to multiply all the terms of the equation by x minus 1. Okay, here solution, multiply by x minus 1. The first one will be x multiplied by x minus 1. Okay, here again, here you have 2 over x minus 1, and you multiply all the terms of the equation by x minus 1. Okay, so x minus 1 will cancel x minus 1, so the result will be equals 2. Okay, so here x will be multiplied by x minus 1, 2 over x minus 1 multiplied by x minus 1, the result is equal to negative 2 because we have a negative sign, and the last one will be 4 multiplied by x minus 1. Okay, 4 multiplied by x minus 1. Now we are going to distribute x over the 2 terms of the bracket x minus 1, and we are going to distribute 4 over the 2 terms of the bracket x minus 1. Okay, x multiplied x will be x power of 2, x multiplied by negative 1 will be negative x minus 2, 4 multiplied by x it will be 4x, 4 multiplied by negative 1, this is equals to negative 4. Okay, so now we have x power of 2 minus x minus 2. Okay, x times x equals x power of 2, x times negative 1 will be negative x, and negative 2 will left over. 4 multiplied by x minus 1, it will be 4x minus 4. Okay, let's put it in the form, the standard form in the quadratic equation. So 4x minus 4 will go to the other side. So we will have now x power of 2. Here we have negative x, and 4x will go to the other side. It will be negative 4x. So the result will be negative 5x. And we have negative 2, negative 4 go to the other side. So it will be negative 2 plus 4. Negative 2 plus 4 will be equals to 2. Now we put it in the standard form. So A will be equals 1. Excellent. B, it will be negative 5. And C, it will be equals to 2. A equals 1, B equals negative 5, C equals 2 by using the discriminant B power 2 minus 4AC, B power 2 negative 5 power 2 minus 4 multiplied by A, which is equals to 1, multiplied by C, which is equals to 2. So the result will be 25 minus 8 equals 17. So the discriminant again is a positive number. The discriminant again is positive number. Why? Because 17 is a positive number. So now we can say that the quadratic equation has two real and different roots. So the quadratic equation has two real and different roots. Okay? Let's go to another example. Here, this is one of the very important example in this class. Okay? Let's solve it together. Here, x here you have x here we have x over x minus 1 plus x over x plus 1 equals 3. How can we add the two fractions? Here we need to add the two fractions. In this case we have two solutions. The first solution we discussed it before by multiplying all the terms of the equation by x plus 1 and x minus 1. You can multiply all the terms of the equation by the two denominators x plus 1 and x minus 1. But here you can revise how we can add two algebraic fractions together. To add two algebraic fractions together, you can see here we are going to multiply the denominators together. We are going to multiply the denominator together. So it will be, here we will write x minus 1 multiplied by x plus 1. Okay? The color is not clear. Let's try another one. Here we are going to multiply the denominators together. X minus 1 multiplied by x plus 1. We will write it in the denominator. Then we are going to cross multiply x multiplied x plus 1. And we will write x multiplied by x plus 1. Okay? X multiplied by x plus 1. And here we are going to multiply x times x minus 1. So the plus sign will be left over, and we are going to multiply x multiplied by x minus 1. All of this equals to 3. Again, first, the two denominators, we are going to multiply the two denominators together. So we will write x minus 1 multiplied x plus 1. Okay? And we are going to cross multiply x, cross multiplication, x multiplied by x plus 1. And the other x will be multiplied by x minus 1. Okay? And all of this equals to 3. Okay? So the solution, it will be x multiplied by x minus 1 plus x multiplied by x plus 1 over x plus 1 multiplied by x minus 1. All of this equals to 3. Okay? Now we are going to distribute and collect the like terms. Let's start it together. Now we have x multiplied by x, so it will be x x multiplied by 1, x multiplied by x, x power of 2, x multiplied by 1 equals 2x. Again, x multiplied by x, it will be x power of 2, and x multiplied by negative 1, it will be negative x. And we are going to multiply the denominators together. Here the denominator are x minus, the denominator is x minus 1 multiplied by x plus 1. X times x, it will be x power of 2. Negative 1 multiplied by positive 1, it will be negative 1. All of this equals to 3. So this is the answer here. X power of 2, x power of 2. Here x power of 2 minus x, okay, plus x power of 2 plus x, okay, over x power of 2 minus 1. Here you have negative x and x. Negative x will cancel x. And x power 2 plus x power 2, it will be 2x power of 2 over x power of 2 minus 1. Okay? As you are going to see it right now. Okay? Here x power of 2 plus x power of 2, this is equals to 2x power of 2. Okay? 2x power 2 will left over, and we are going to cross multiply. Cross multiplication, okay? Here you can write 3 over 1, and you are going to cross multiplication. 3 multiplied by x minus by x squared minus 1 will be equals 1 multiplied by x power 2 plus x power 2, which is equals to 2x power of 2. So we can write 2x power of 2 equals 3 multiplied by x power of 2 minus 1. Distribute 3 over the two terms of the bracket. It will be here 2x power of 2 equal 3x power of 2 minus 3. Now we want to put it in the form of a quadratic equation, in the standard form of the quadratic equation. So 2x squared will go to the other side. So the result will be x squared minus 3 equals 0. X squared minus 3 equals 0. Here a equals 1. B, here we haven't, there is no coefficient of x. X here is not exist in the equation. So the coefficient of x, which is b here equals 0. Okay? b equals 0. The discriminant will be b power 2 minus 4ac. Okay, it will be equals to, here b squared equals 0 minus 4 multiplied by a, which is equals to 1 multiplied by c, which is equals to negative 3. The discriminant equals 12, which is a positive number. So the quadratic equation has two real and different roots. Okay, so the quadratic equation has two real and different roots. Okay, let's go to another idea. Here, this is an exercise for you. Determine the types of the following quadratic equation. You can pause the video and answer it by yourself. Example, find the value of k belongs to R, which makes the two roots of the equation 3x power of 2 minus 6 plus k equal 0 equal, and find the two roots. Okay, we are going to solve first the first part of this equation together, then we are going to complete it by using the PowerPoint. Let's read the example. I'll read the question slowly. Okay, here he told me that the quadratic equation has two equal roots. The quadratic equation has two equal roots, and he wants to find the value of k. Okay, since the quadratic equation has two equal roots, This is means that the discriminant equals 0. We all know that if the roots are equal, then the discriminant equals 0. What we mean by the discriminant equals 0, that b power 2 minus 4ac equals 0. Okay, let's substitute. Here, a, you can see that a equals 3, b equals negative 6. Okay, so negative 6 power of 2 minus 4 multiplied by a. A is the coefficient of x power of 2 equals 3 multiplied by c. Here c is the term free of x. Here in this equation the term free of x is k. So we will write multiplied by k. All of this equals to 0. Negative 6 power 2 will be equals 36. Negative 4 times 3 equals negative 12. Negative 12 times k will be equals to negative 12k. All of this equals to 0. Negative 12k go to the other side. 36 equals 12k. Divide the both sides by 12. So you can find that k equals 3. So k equals 3. Now we find the value of k, which makes the two roots of the quadratic equation 3x power of 2 minus 6x plus k are equal. Then he asked you to find the two roots. Okay? Since the two roots are equal, then the value of each one of them equals negative b over a. Since again the two roots are equal, then the value of each one of them will be equals negative b over 2a. This is, you can take it as a rule. Since the two roots are equal, so the value of each one of them equals negative b over a. Okay? negative b over هنشوفها مع بعض دلوقتي negative b over 2a. The two roots are equal. Discriminant equals 0. Okay. Discriminant equals 0. B power 2 d equals b power 2 minus 4ac. Okay. Negative 6 minus 4 times 3 times k. Okay. So 36 minus 12k. Since the two roots are equal, the discriminant equals 0. 36 minus 12k equals 0. Okay, 12k equals 36. That is to say that k equals 3. Now we want to find the quadratic equation will be 3x power of 2 minus 6x plus 3 equals 0. Okay, each root will be equals to negative b over 2a. Negative b over 2a. And I will explain it for you. Here you have x, sorry. Okay, here you have, we all know x equals negative b, positive or negative, square root the discriminant, which is b power 2 minus 4ac, over 2a. Since the quadratic equation has two equal roots, so the discriminant equals 0. So the result will be the two roots equal negative b over 2a. The two roots will be equals to negative b over 2a. So here each root will be negative b over 2a. Negative b equals 6. Negative b. We know that from the quadratic equation that b equals negative 6. Okay, b equals negative 6 over 2 multiplied by a by 6 over 2 multiplied by 3. The result will be equals to 1. So each of the two roots equals to 1. Okay? Okay. Thank you so much. Until we meet again next time, goodbye and good luck.